Hello, everyone. This is Dr. McElhenney, and today I have the lecture covering chapters 12, 14, 15, and 16. It'll be a brief overview. As always, your text is the final authority on all this subject matter, and I'm just going to do a high-level overview. So I encourage you to really dig into your textbook so that you have a fuller understanding of the content of this lecture. How are you? This slide just shows that sampling is the process of selecting representative units of a population and gives some broad definitions of some of the terminology that you'll be seeing as you read through your research articles. Understand that the population is every person, everything that belongs in that set. It could be people or animals, objects. The target population is the set of cases which the researcher would like to make generalizations. So maybe it's people in a specific area. The accessible population are the people or the population that meets the criteria that the researcher hopes to be able to collect data from. As you read through your selected research article, in the methodology section, the researcher should delineate the inclusion and exclusion criteria. So it defines the characteristics that the subjects or the participants need to have in order to participate in the research study. And if you remember from the last lecture and from previous chapters, quantitative research needs to have a lot of controls so that the researchers can make generalizations to the larger population, and also so that criteria can't explain the effects or the outcomes of the dependent variables. This slide just has some more vocabulary on it: sampling, sample, and representative sample. Sampling is the process that the researchers use to select a portion of the designated population. And the sample is that set of elements. It's those participants in the research study. The last vocabulary word is element. I don't often see the word element in research studies that I've read, but just note that that's another possibility when you're reading through your research study. This slide shows the two different types of sampling: non-probability and probability sampling. And we'll talk a little bit about these two types of sampling in the coming slides. Non-probability sampling is non-random and it's less representative. You might, as you read through your research articles, see the terms convenience sample or quota, purposive or network or snowball sampling. These are all examples of non-probability sampling. Probability sampling, these are more representative of the whole population, and they're done randomly, meaning that each of the elements in that population has the same chance of being selected or assigned than every other element in that total population. So you may see when you read through your research article in the methodology section, simple random sampling, stratified random sampling, or multi-stage or cluster sampling. These are important things to note as you're reading through your research article. So again, these non-probability sampling methods, your textbook does an excellent job of expanding on all of these things. I am not going to read from this slide, but you can read more about these different sampling methods in your textbook. And again, these are definitions and a little bit more information about probability sampling, that random sampling. I would refer to your textbook in order to get a deeper understanding of these sampling methods. I do want to take a little bit of time talking about the sample size because when you're reading through your quantitative research study, I want you to note how big your sample size is. Generally, researchers should use the largest sample possible. Ideally, everyone in the population, but that's not feasible. So in order to determine how big the sample size should be, researchers should do a power analysis, and this should be done before the sampling actually occurs. So make sure that when you're reading through your research article in the methodology section, look for the sample size and see whether the researchers did that power analysis in order to determine the good sample size to be able to apply these results and generalize them to the large population. This slide and the next slide are those questions that you should be asking yourself while you're reading that research article when you're reading about the sampling method. So read the question and go back to the research study to see how your research study stacks up against what you've learned about that particular question. Next, we'll talk about the data collection procedures. And it's really important for the researchers to maintain objectivity and free from bias. And that data collection procedure should be systematic. It should be the same for every subject, every participant. Other considerations about data collection are fidelity, the consistency and the quality of the data collection methods, and determining what measurement to use in a particular study. That might be the most difficult and time-consuming step in the study design, finding those measurements that will measure what the researcher actually wants to measure. Examples of data collection methods might be observation, self-report, physiological data like heart rate or blood pressure, and existing data. I know we talked about in one of the previous lectures, retrospective data, or perhaps a researcher has a large amount of data and another researcher wants to use that data to draw their own conclusions about relationships between different variables. Other things to take into consideration are errors. There are always errors in data collection. They could be measurement errors. That's the difference between what really exists and what is measured. Could be a random error. So we don't know why it occurs. It occurs in a random way. Or systematic errors when the scores are incorrect, but they're always in the same direction. Another way researchers collect data is by observation. So it's important that the researchers that are collecting data, that their observations are recorded in a consistent manner in alignment with the study's aims or objectives. There should be a standardized and systematic plan for the observation and the recording of data, and the observation should be checked and controlled. We're going to get into reliability and validity in just a few slides, but when you are reading through your quantitative research study, if there's an observation method of data collection, you'll want to see whether whether there was training for the researchers to collect data, or whether there was a manual for data collection. And you'll also probably want to know whether the different observers, whether there was some comparison for accuracy between all the observers. These are important things when you're reading through your quantitative research study. There are also unstructured observational methods. I would be a little bit leery about these because we're not sure whether they would be consistent. Also, anecdotes or summaries of particular observations may be in some of your research studies. Typically, for quantitative studies, it's a structured observational method. So the researchers specify in advance what behaviors are to be observed, and they're standardized like checklists or forms or something like that. And the observers need to be trained and validated on their training so that all of the observers are recording the observations in the same way. Do the participants know that they're being observed? Is there an intervention? Again, these are some things that you'll want to pay attention to as you're reading through your research study. Are the participants participating in a debriefing? Are they allowed to revoke their data if they don't agree to having it in the research study? If the participants are aware of the observation, there may be some effect called the Hawthorne effect. If they know that they're being observed, their behavior may be different than what it normally would have been had they not known that they were being observed. So again, things to keep in the back of your mind while you're reading through your research study. Probably one of the most common forms are self-reporting methods. So interviews, structured questionnaires, these are the most common data collection methods in the social sciences, including nursing. Interviews are usually limited to qualitative, and we'll get more into that in the coming weeks. I believe in week 5 about qualitative studies. Questionnaires, you're going to see those are very frequent when you're looking at the social sciences, including nursing. So questionnaires, paper and pencil, digital surveys, things that are measured on a scale, a Likert scale. They're very common data collection methods in these social sciences. I mentioned physiological measurement earlier. So blood pressure, heart rate, respiratory rate, temperature, but it also could be biological samples, blood work, x-rays, cultures, and things like that. And finally, that existing data, whether it's a retrospective electronic health record data mining for data collection, or whether a researcher is using someone else's data to do a secondary analysis. It's just another way to collect data. Something else that I don't see very often, and you probably won't run into this with your research studies, are construction of new instruments. It's very complex, it's very time consuming, and there are specific prescribed steps to development. I would not recommend critiquing one of these construction of new element articles for the purposes of this class. Just be aware that these types of articles are out there. So this slide and the next 5 are those critical appraisal questions that you'll want to ask yourself and go back to your quantitative research article and look specifically at the data collection methods just to see how your article is stacking up against that gold standard in the textbook. Next, we'll talk about reliability and validity. Reliability measures the consistency of the data, while validity measures the accuracy of the data. And then that last vocabulary word is error variance. And that's the variability attributed just to error, not because of anything else. Errors in measurement can happen in a variety of ways. So while you're critically reading through your research article, see whether you can identify whether there could be some errors in measurement that the researchers collected. This slide and the next three talk about validity. So validity is the extent to which an instrument measures what it actually says it's going to measure. The measure can be reliable but not valid, but a valid instrument is always reliable. And there are several different types of validity. Content validity represents the universe of content or the domain of a given variable construct. It says that it's measuring what it says it's measuring. There's also a content validity index. So if the researchers report on content validity, you should look for a content validity index. It should be a number. The most rudimentary type of validity is face validity. And basically, the instrument gives the appearance that it's measuring that specific concept. In order for some kind of an instrument to be valid, it has to undergo validity testing. And these are some of the examples, this and the next two slides, of that validity testing. You may need to watch out with a critical eye to see whether your research article stacks up and the instruments stack up for validity testing. Next, we'll talk about reliability. And reliability is just that consistency of the scores. Does the instrument produce the same results with repeated testing? Typically, when authors mention the reliability, they will also include a statistic. And those tests of reliability are listed on the slide. For example, a Likert scale often has a Cronbach's alpha score associated with it. So the higher the score, closest to 1.0, you're never going to see a 1.0, but the closer that reliability score gets to 1, the better the reliability is. So you're looking for those instruments with at least a 0.8 or a 0.7 that'll tell you that the instrument is reliable. These are examples of reliability testing. It's a little bit in the weeds. However, you may want to look at that part of the textbook as you're reading through your research article, if your research article describes that test of reliability. I do want to call out on this slide the inter-rater reliability on this slide. We talked about observational data gathering in a previous slide during this lecture. And if you have a research study that collects data through observation, you'll want to look for this inter-rater reliability factor. And it should be fairly high, close to 1.0 for that reliability factor. I don't typically see these things included in the research articles that I've read recently. And if you want to read more deeply about these, you can consult your textbook. So while you're looking and reading through your research report, you'll want to make sure that if there's an instrument that the researchers also report the validity and reliability and include that in your critique. This slide and the next one are those questions that you want to ask yourself as you're reading through that methodology section to analyze and determine whether the reliability and validity of your selected quantitative research study were strong or weak. Next, we're going to dive into some data analysis. And I know that typically this is not the most exciting part, but I find it exciting. I like math. You should be looking for descriptive statistics in the results section. Descriptive statistics describe and summarize the sample of participants. You should be seeing mean, median, mode, those measures of central tendency, as well as variability like range and standard deviation. Also included may be correlation techniques. These may be in the form of scatter plots, and they will show relationships between two variables. Quantitative research studies also have inferential statistics, and these are used to predict and to generalize. They analyze, they test hypotheses, and they answer the research questions. So all of these things should relate back to the research question, and they're used to draw conclusions that extend beyond the immediate data of the study. Since we're talking about quantitative research studies, the measures should be assigned numbers to the variables or events according to the rules. Now, in my research study, I measured the concept of psychological empowerment, but that's kind of a nebulous concept. So the way I measured psychological empowerment was using a Likert scale. It was an instrument with 12 different statements on it, and then the participants, they indicated the amount of agreement or disagreement, and they were assigned numbers. You also should be aware of the level of measurement, and you can read those 4 different levels of measurement on the slide. Nominal data is used to classify variables or events into categories. It's the lowest level of measurement, and it allows for the least amount of statistical manipulation. Usually it's just dichotomous, only using 2 values like true or false, yes or no, male or female. Or it could be categorical that have mutually exclusive categories. Ordinal data shows rankings. So think about like first grade, second grade, third grade, or freshman, sophomore, junior, things like that. It has limited mathematical manipulation, but there's always a rank order that the data are in. The next one is interval measurement, and this shows on a scale with equal intervals between numbers, and this allows for more manipulation of the data. So, for example, there are equal intervals between the numbers 1 and 2 and 2 and 3, or the temperature, 32 degrees Fahrenheit to 33 is the same scale as 33 to 34. The highest degree of measurement is ratio measurement, and it shows the rankings of events or variables on scales with equal intervals and absolute zeros. Going back to descriptive statistics, oftentimes we'll see a frequency distribution, and sometimes it's in the form of a histogram or a frequency polygon. Talking about measures of central tendency again, you'll be looking for the mean, median, and mode. And this is important for researchers to look at this because they should be looking for a normal distribution, like a bell-shaped curve, so that they can then perform the correct analyses on, the correct inferential analyses on the data. So they do look for that normal distribution curve, so that half of the data are above the mean and half of the data are below the mean. They should be looking to make sure that most of it falls within 2 standard deviations of the mean, and almost all of it falls within 3 standard deviations of the mean. So as you're reading through your research articles, see whether the researchers describe these central tendency statistics and note whether they are normally distributed or not. How are the data variable? What's the range? Are there outliers? What's the standard deviation? Is it very small? Is it very large? These are things to, again, to read with a critical eye in order to determine whether the correct inferential statistics are done. Inferential statistics are the ones that allow the testing of the hypothesis using that data obtained from those samples. Inferential statistics are used to do hypothesis testing, and I hope you remember from a previous lecture that there are 2 hypotheses that are tested. One is the research hypothesis, that the researcher believes that will be the outcome of the study. The other one is the null or the statistical hypothesis, which means that there isn't any actual change due to the intervention. Inferential statistics measure probability. For example, what are the chances of obtaining the same result from a study that can be carried out many times under the identical conditions? That's where the inferential statistics come into play. It's the notion of repeated trials that allow researchers to use probability to test hypotheses. While you're reading through the results section, you'll want to keep an eye out for type 1 and type 2 errors. Type 1 error is when the researcher rejects the null hypothesis when it's actually true, and a type 2 hypothesis occurs when the researcher accepts the null hypothesis that is actually false. And these are difficult concepts. I would really encourage you to read through Lobiondo, Wood, and Haber to get a better and deeper understanding of these 2 types of errors. You'll also want to look at the level of significance, or the alpha level. Typically, in nursing research, healthcare, and social sciences, that level of significance is set at 0.05. That's the probability of making that type 1 error, the probability of rejecting a true null hypothesis. We also should talk about the difference between a clinical and a statistical significance. When a researcher tests a hypothesis and finds that it is statistically significant, it also means that the finding is unlikely to have happened by chance. This could mean that it is also clinically significant in the social sciences. There could be a time, though, that there is no statistical significance, but the findings do have some clinical significance. In that case, the researchers would probably recommend future testing. Other terms that you should be familiar with are parametric and non-parametric analyses. Parametric analyses are done when the data are normally distributed. Non-parametric analyses are done when the data are not normally distributed. So when you're reading through the analysis section of your research study and the researchers determine that the data are normally distributed, they should be conducting parametric inferential statistics analysis. If they determine that they're not normally distributed, the researchers should be performing non-parametric analyses. Perhaps your researchers are looking to test the difference, a change in a score from one time to the next time. Typically, this is done in experimental and quasi-experimental designs, and a lot of times it's done with a t-test. It just measures the difference in the mean between those two different scores. You may see an ANOVA or an ANCOVA performed on the data in the research study. The ANOVA, or analysis of variance, tests whether the group means differ, but it looks at each pair of means separately. It considers the variations between groups and within groups. An ANCOVA just measures the differences between the group means, but it uses another statistical technique to look at covariance. And yet another form of inferential statistics is a MANOVA, and it is used to determine differences in group means, but also when there is more than one dependent variable. Next, we'll look at non-parametric statistics. For example, the chi-square. These are usually used with nominal data, and smaller sample sizes are used. The Fisher exact probability test is used. Another type of inferential statistic is to test relationship, and these explore the association between two or more variables. Usually it's associated with non-experimental designs that provide a lower level of evidence. These are also some other tests of relationship, the Pearson product moment correlation or Pearson correlation. You may see it referred to as Pearson's R, the phi coefficient, a point biserial correlation, and a Spearman rho. So if you're looking, if you see these and are reading those through your quantitative research study, dig into the textbook a little bit more to have a deeper understanding so that you can adequately analyze your research article. Finally, there are more advanced statistics like multiple regression and factor analysis. And these are advanced statistics. If your research article does use any of these, I would encourage you to get into the textbook and read a little bit more to deepen your understanding. In these last 3 slides, these are those critical appraisal questions that you'll want to ask yourself and then go back to your research article to compare and contrast what the authors of that research study wrote so that you can stack it up to determine whether that question or that section of your research article is strong or weak. Remember too that while you're doing your analysis, you always want to go back to the research question that the researchers wrote toward the beginning of the article. Is what you're reading relating to those research questions or study aims? And I hope this lecture was helpful for you as you continue to critique your articles.